Okay, this is chapter 7 notes. This first part. Wait, let me open the solutions. Yeah, these are the solutions over here. Uh, this first part is very, very easy. I'm not gonna read through the notes because, well, what, you know, like, okay. Um, yeah, not all the questions in the notes have answers to them. Uh, it's the questions that look like this that have a number beside them. Those have an answer. So you just go to the course revision document and you go to question 103 and the answer is right there. Okay, that's how it works. So like question one over here, the atomic nucleus contains, what does a nucleus contain? We know it's nucleons. Nucleons are what represents protons and neutrons. Okay, and we know in the nucleus there are protons and neutrons. Uh, Protons, yes. Electrons, obviously not. Electrons are outside. Neutrons, obviously, yes. Give it a negative charge, obviously not. I'm gonna go through the questions only. How do the masses of protons, electrons, and neutrons compare? We know that the mass of a proton is 1 AMU. We know that the mass of an electron is 1 over 1840 AMU. And we know the mass of a neutron is also 1 AMU. Okay, they're not going to ask you what's the exact number. If they say it's negligible, it's also negligible, by the way. Uh, but like if it comes with a multiple, it's 1 over 1840. What determines the mass of an atom? It's going to be the protons and the neutrons. What determines the size of an atom? What determines the size of an atom? It's not here. Hold up. Yeah, I can't really find what determines the size of an atom, but it should be the same thing, the mass as well. They don't ask something like this. For part B as well, when they said what determines the mass of the atom, you can also just say the mass of the nucleus. Okay, you can say the mass of the nucleus determines it. And now, before continuing, in case they ask this, okay, the atomic diameter is the distance between two adjacent nuclei. So basically, what's the distance between this nuclei and this nuclei? It's 10 to the power of negative 10, in case it comes. Okay, and then the diameter of the nucleus, saying the size of a nucleus would be 10 to the power of negative 14 in case it comes. Uh, what is common to nuclei of the same element? Uh, if they're the same element, what's the same? Anyway, obviously, since it's the same element, it's going to be protons, okay, and the nuclear charge. We know that if it's the same element, it doesn't necessarily mean they have the same mass. Because, for example, chlorine has 17 and 35, and also has chlorine 17 and 36. So in this case, it would have 18 neutrons, and in this case, it would have 7, no, 35, 18, 19 neutrons. Okay, so neutrons aren't necessarily the same. The mass isn't necessarily the same. Uh, and the nucleons, which also again has to do with the neutrons, isn't necessarily the same. So the only thing conserved would be the charge of the nucleus and the number of protons. So the nuclear charge and the protons. Okay, atoms become positively charged ions by losing an electron, right? And negatively charged ions by gaining an electron. Question 4. When ions are formed from neutral atoms, energy may either be absorbed or released. In what case is energy absorbed? When would you have to absorb energy? Uh, when do you have to absorb energy? And in what case? When you have to absorb energy, that means you have to put in a force. Okay, and when do we have to put in a force? Remember that this is an atom, and it has a positively charged nucleus, and it has negatively charged electrons around it. Okay, so when we make it an ion, we're either removing an electron, right? We're either losing an electron to make it positive or gaining an electron to make it negative. Okay, when do we have to absorb energy? So when we lose an electron, that means we're pulling it out. When you're gaining an electron, that means the electrons is being pushed over here. And obviously we know since it's negative positive, it's going to be naturally attracted to the nucleus. So we don't really have to put in a force. But since it's being attracted to the nucleus, if I want to pull it out, I need to put in a resistance force resisting the force of the electric force, the electric attraction between the positive and negative. Okay. So when do we have to absorb energy? When you want to make a positive ion, when a positive ion is formed. In what case is it released? Released is the opposite. When do we not have to put in energy? When the electron is gained, right? When the electron is absorbed. And in that case, when an electron is gained, when a negative ion is formed. Explain, I don't, what am I going to say? I think it's explained here actually. Formation of positive ions, energy, yeah, when you want to make it positive, it loses an electron, and it's needed, energy is absorbed to put an electron, okay, okay, blah, 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 blah. And then for a negative ion, it gains an electron to become negative, and it's released when the electron is captured by the atom. Okay, question 5. In isolated atoms, how do electrons move and where are they found with respect to the nucleus? So the answer to this question is actually in this paragraph over here. Electrons of an atom can be found anywhere. Okay, we have no idea how they move or where they are. Okay, but we always know that they have a higher probability of being near to the nucleus. Okay, to help you understand this, obviously, since the nucleus is positive, okay, and electrons are negative, obviously it's going to have a higher chance of being here than here, because it's going to be attracted to the positive nucleus. Okay, so we know, is it having a circular orbit? No, we don't know. In egg-shaped orbits? No, we have no idea how they move. Yes, an atom has no sharp boundaries, so its electrons could be anywhere. Well, technically, no. Okay, but they have a higher probability of being near to the nucleus than farther away from. That's what we want. We want it being nearer to the nucleus than farther away. It's not. It could be anywhere. Okay. Which is true about the term atomic number? It is the number of atoms in a given sample? Obviously not. It's the number of protons? Yes. It's the number of neutrons? No. It's equal to the number of electrons in a neutral atom? Yes, that's important. Is it Avogadro's number? Obviously not. It's the charge of the nucleus of an atom, and its symbol is Z. Yes. Question, okay, 7. What is true about the mass number? It is the mass of a given nucleus, and its symbol is A. The number of protons in the nucleus? Protons? No. It's the number of neutrons? No. It's equal to the number of nucleons. Yes, nucleons is protons plus neutrons, and it's the total number of protons and neutrons. Yes. Okay, a nucleus is represented by AXZ. Okay, blah, blah, blah. Question 4. Deduce the number of subatomic particles using A and Z. The atoms of an element are represented as AZX. Which letter in the above atomic symbol corresponds to the mass number? A. The atomic number, Z. The symbol of the element, obviously X. Okay, the element carbon is represented as this. How many neutrons does it contain? Neutrons is always the one up minus the one down, so 6. How many protons? Obviously, the number down, which is 6. How many electrons? 6. Question 5. Fill in the table to determine. Okay, I'm gonna only do the one for chlorine. You guys do the rest. Or no, I'll do the first two. Chlorine, how many neutrons does it have? You do 35 minus 17, 18. Okay, how many protons does it have? 17. How many electrons does it have? Be careful that there's a charge, okay? We know it has 17, but since it's minus, that means it gained an electron, right? Gained an electron. So 17 plus 1 extra electron, so 18. Okay, here, neutrons 27 minus 13, 14. Okay, protons will be 13. Protons doesn't change, okay? The only thing that could change is electrons. Since its charge is plus 3, that means it lost 3 electrons, صح? So 13 minus 3, it's 10. Okay, here neutrons 23 minus 11 is 12. Okay, protons will just be 11, and the the electrons would be 11, but it lost 1 to become plus 1, so 11 minus 1, 10. Okay, here neutrons 32 minus 16 is going to be 16. Protons would be 16. Okay, and then electrons, since it gained 2, it's 16 plus 2, that's 18. Okay. Question 10. Complete the file. Okay, this is the same thing. I'm gonna skip it. The only tricky one I do would be this one, barium here. They gave you its protons and gave you its electrons. So can you find out the mass number? Yes, you just add these two up. So you get 137. Okay. Can you find the electrons? We know the number of protons it has, and since it's plus 2, that means it's plus 2. So 56 minus 2 is 54. What's the atomic number? It's gonna be the same as the protons, so 56. Okay. You guys do the rest. Question 7. Consider the element sodium of nuclear symbol. Okay, what is the atomic number of sodium? Obviously 11. What does the atomic number represent? Okay. I know the atomic number represents the number of protons in the charge of the nucleus, but maybe it's something. Oh, okay, they just said the number of protons. Because I remember in the quiz, somebody sent me a question. It was a bit different. Consider the nucleus, chlorine. What is its atomic number? 17. What is its mass number? 35. No, 35. Yeah. Okay, how many nucleons does it contain? Same as the mass number always. How many neutrons does it contain? 35 minus 17, 18. How many electrons would its neutral atom contain? Obviously 17. How many protons does it contain? 17. Okay, questions like these we always like to see. What is it? Is this the same thing? It's the same thing, no? Ah, no, they just made it minus. Okay, so if it's minus, that means it has one extra electron, right? So it would be 18 electrons now. Okay, I'll skip this. Okay, I remember this game. What is the mass number for this atom? Obviously, mass number, you count the number of protons and neutrons. In this case, it's 4. What does the mass number represent? The number of protons plus neutrons, right? Yeah, the protons and neutrons. Question 14. Okay, atoms are composed. Okay, this is a top question. Atoms are composed of subatomic particles. Identify the subatomic particles given the properties. Which one has a charge of -1 electron? Which one has a relative mass of 1 over 1840? Which one is the really small one? Electron. Are found in the nucleus with a relative charge of +1 proton. So you could just say proton. Have relative charge 0, obviously neutron. The table below provides information about atoms and ions. Okay, let me see. Okay, yeah, so they gave us this X here. Okay, they gave us the atomic number is 19, and they gave us the number of neutrons is 20. And this is the symbol of it. Okay, do we know how many electrons are in it? We know that it's +1, so obviously it lost, right? It lost 1 electron. So if it has 19 uh, as the atomic number, then the electrons will be 18. 19 minus 1. It would have been better if I started off with writing proton. Okay, obviously if its atomic number is 19, protons here. I should have started off with the protons. Okay, and the mass number, you just do the atomic number plus the number of neutrons, or the number of protons plus the number of neutrons, you get 39. And Aslan is giving you 39. Here, okay, let's look here. What's the number of neutrons? 19 minus 9, 10. The number of protons is 9. And the number of electrons, since it's a neutral atom, it will be the same as the number of protons. Okay. Uh, okay. Before going down, uh, I've never seen them ask a question on this. They could like decide to bring it. Okay, protons and neutrons are made of quarks. Okay, quarks are like smaller than protons and neutrons. They're what make up the protons and neutrons. Isotopes are particles within the nucleus of an atom. No. Nuclei of the same element but having different masses. Yes. Nuclei of the different element. Different element. No. Nuclei having the same atomic number but different mass number. Yes. Okay. These are the isotopes of. Do they ask a question about it? Okay. Okay, yeah, they do. But the isotopes of hydrogen, I really advise you to know them. Realize how, since it's an isotope, then the number of protons stays the same, but the only thing that changes is the mass number or the number of neutrons. Okay. Deuterium. Okay. De for I think it's Latin or French, I don't know. But de usually means 2. Okay, so that means its mass number would be 2, and then tritium, tri for 3, so the mass is 3. And then hydrogen is always 1. So let's say it was 3 at the top, then you can figure out how many neutrons by doing 3 minus 1, you get 2. Okay. Uh, then they ask about deuterium. Deuterium is an element which has a symbol of 1,1H. No, because deuterium has a mass of 2, right? It's an isotope of hydrogen that has a mass of 2, yes. It's an element that has a nuclei of symbol uh, this, yes. A hydrogen atom whose nucleus consists of a proton and a neutron, yes. Found in water in quantities less than 1. Okay, I don't know. Is it? Uh, well, they obviously wouldn't ask this. Uh, yeah, I don't think they'd ask something like that. Is it? We never saw anything in the book about it, though. I didn't see anything in the book about it. Okay, so I went to Google and I'm not finding anything. Uh, yeah. So if you figure it out, just put it in the comments, I guess. I don't know if this is correct. Question 9, hydrogen. Okay, now for question 9, define isotopes. Isotopes are just atoms of the same element having the same atomic number but different mass numbers. If you define it like this, you get full. Okay, given the nuclear symbol, give the nuclear symbols for each 3. Okay, here it has a charge of 1, right? Let's just call it X. Okay, it has a charge of 1, and the mass of it will be protons plus neutrons, and since we have no neutrons here, it will be 1 plus 0, so on. Here we have 1 proton, and then its mass will be 1 plus 1, so 2. And here it's 1 again, and 2 neutrons, so 1 plus 2, 3. Okay. Uh, the average mass, I think here. Okay, which of the following determines the normal chemical properties of an element? What determines it? Hold up. Yeah, it's actually right here. The chemical properties are determined by the atomic number. Okay, because now how do we tell what is the element? It's how do we know what the element is? We can tell by the protons. We can't tell by the mass because the mass changes. Okay, but one thing that every nucleus of the same element has is the same number of protons. So how can we tell what it is from the atomic number? Okay, so the atomic number is E. Uh, Question 2. Okay, this is the average molar mass thing. Uh, Chlorine has 2 stable isotopes. This and this assume the mass of. Okay, blah, blah, blah. If the average molar mass is 35.5, find the percentage of each isotope in nature. Okay, before doing 2, I'm gonna do 3. Okay, just so you can be familiar with the formula. Okay, chlorine in nature consists of 75.4% of 35, 24.6 of 37. Find the average molar mass. Okay, average molar mass, okay, is like this, is equal to percentage M1 times M1 plus percentage M2 times M2 over 100. Okay, so in this case, it's going to be 75.4 times 35 plus 24.6 times 37 over 100. Okay, uh, let's put this on a calculator. 75.4 times 35 plus 24.6 times 37 divided by 100. You get this. Okay, find the average molar mass. Let's put it to 3 significant figures. It would be 35.5, and the unit for it is G slash mol. Okay, grams per mol, right? Yeah, grams per mol. You can put it without any, it doesn't matter. Okay, now question 2. Okay, why I did question 3 is because here you can actually use it. It's a direct application of the formula. Here you have to play with the formula a bit. Okay, when you're asked to find the percentages, you'll always be given 2 isotopes. You won't ever be given 3. Okay, we know the formula is percentage M1 times M1 plus percentage M2 times M2 over 100. Okay, we don't know the percentages, so let's just call it percentage M1, okay, times mass 1, which is 35, plus percentage M2 times mass 2, which is 37, over 100. Okay, so can we find a correlation between the percentage of M1 and percentage of M2? We know that the percentage of M2 is equal to 1 minus the percentage of M1. Right? Because let's say this one was 10%, then this one would be 90%, right? So let's rewrite this as percentage of M1 times M1 plus 1 minus percentage of M1 times M2 over 100. Since it's a bit confusing, okay, to use percentage M1, I'm just going to replace this and put X, okay? Let's just put X and 1 minus X. Okay, now let's just solve this. We know that the average molar mass is given. It's 35.5. Okay, so how do we solve this? Multiply by 100 on the other side. You're going to get M1 times X plus 1 minus X times M2 equals 3,550 because we multiplied by 100. We know mass 1 is 35. We know mass 2 is 37. So it's going to be 35X plus 1 minus X times 37. Okay, equals 3,550. So now you just have to do a bit of math. Just distribute the 37 into 1 minus X. You're going to get 35X plus 37 minus 37X. Because 37 times 1, 37 times minus X equals 3550. Okay. 35X minus 37X is going to be minus 2X. Take 37 to the other side. I'm just going to do this on the calculator. 3550 minus 37 divided by 2 Okay, this can't be right. What? I did something wrong. Okay. Why did I put 1 minus x? It should be 100 minus x because we're working with percentages. Anyway, so let's solve this again. We said x times mass 1, which is 35, okay, plus 100 minus x because it's a percentage, times mass 2, 37, okay, over 100 equals 35.5. Okay, now we solve it normally. 35x plus 37 times 100, 30,700 minus 37x equals 3550. You subtract by, okay, so it becomes minus 2x equals minus 150. You're gonna get x equals 75. Okay, so the percentage of 35 of this 35 is gonna be 75%. Okay, and then the percentage of this 37 would be 25% because 100 minus 75. Okay, is this correct? Chlorine is 75% this and this. Okay, 25%. Yeah. Okay, and then they didn't ask for mass, so we don't put grams per mole. Okay. uh, Identify the diagrams that represent atoms. Okay, if it's an atom, you should know that the number of protons is equal to the number of electrons. This always comes in our AMS and periodic. Over here would be an atom, over here would be an atom, over here would not be an atom, over here would also not be an atom, and over here would be an atom. So A, B, E. Okay, identify the diagrams that represent a positive ion. So greater protons than, so we don't know, not this, not this, not this. Greater protons than electrons, obviously it's going to be this one, so C. Okay, and then which ones are isotopes of the same element? So which ones have the same number of protons, but different number of electrons? Okay, here we have one proton, here we also have one proton, here we have also one proton, here we also have one proton. Wait. Okay, after looking at the question one more time, they said atoms, so we're only talking about the neutral ones. So obviously this one won't, this one won't work because it's charged, and this one also won't work. So we only have a selection from A, B, and E. Okay, and which one from these three have the same number of protons but different number of mass? This one has 2 protons, but these both have 1 proton, so obviously not E. Since they both have the same number of protons but different number of neutrons, that means A and B are my isotopes. Okay, uh, so A and B. Okay, identify the diagram that represents a mass number of 3. Obviously not this. This is 4. Okay, this is 1. Okay, this is also 1. This is 3 because protons and neutrons equals 3. Okay, okay, that's a lot. That's a lot of talking. Okay, element B is placed to the right of element A in the periodic table. We conclude that. Okay, so let's say this is the periodic table. Okay, so we have A here and we have B here. Okay, periodic table. We conclude that element B has one more proton in its nucleus than element A. Yes, because as you go to the right, atomic number increases by 1. Element A has one more proton. No, B has one more proton. Element A and B have the same number of protons, but different number of neutrons in their nuclei. No. The only time they would have the same protons is if they are in the same group. And we're talking to the right, it's in the same row. Which sentence about rows and groups are correct in a periodic table? Elements in one row are called a group. أكيد لا. Elements in one row are called a family. No. Elements in one row are called a period. Yeah. Elements in one group are a column. Yes. Elements in one column have similar chemical properties. Yes. In the periodic table, elements grouped in a vertical column have similar chemical properties. Yes. General statements can be made about the chemistry of elements in one group. Yes. General? General or specific? Okay, I think that's correct. I think general means you can generalize things about them. Okay, the formulas of compounds and the nature of the bonds that hold the atoms together can be predicted from the position of these atoms in the periodic table. Yes, elements in one horizontal row react to obtain an electron arrangement similar to the noble gas at the end of the row. Yeah. Sorry. For part D, it's also correct. Because they always try to obtain the electron arrangement similar to the noble gas, because after reacting they want to be stable. Okay, Elements towards the left are metals. Yes. Okay. All of them are correct for this one. I think. Uh, 15. Elements of group 18 are called noble gases. Why do noble gases exist in nature in a monoatomic state? Because they don't react, right? We know they're stable. How do the melting points and boiling points vary as you go down the group? We know as you go down the group, the melting and boiling points increase. Let me double check. Yeah. Uh, oh, 15. Oh. Yeah. For they are inert, or yeah, they are stable. Okay. And we said they increase down. Um, which property of helium is incorrect? In nature, it's He2. No, it's a noble gas. فأكيد it's monoatomic. It's difficult to liquefy it. I think B is correct. Is it? Okay. It cannot be solidified at any temperature unless it's subjected to pressure. Okay, yeah, so it's difficult to liquefy. That's correct. It has 10 electrons around its nucleus. Obviously, that's wrong. I think you guys know helium is He24. Okay. It reacts with oxygen, so this this is correct. It reacts. It reacts with oxygen. Obviously, no. When it liquefies at 4 Kelvin, it conducts an electric current. I didn't see anything to do with this. Uh, properties of helium. It's a monoatomic gas, has a very low boiling point, cannot be solidified at any temperature unless subjected to pressure. It's unreactive. They probably won't get this question since they didn't give us enough information about it. Question 16. What is the trend in the boiling points and the melting points of alkali metals? For alkali metals, we said it's the opposite. So as you go down the group, the reactivity increases, but the melting point and boiling point decrease. Uh, and they're summarized here also. Uh, you can see them. Question 17. Which of the following is true about alkali metals? Alkali metals are very unstable. They're very reactive. We know that, yes. They form very stable compounds. No, I don't think they're stable. They react vigorously with oxygen and chlorine. Yes, they do. Alkali metals are very unstable. They react vigorously with O2. And they form, so when after they react, okay, after they react, they form stable compounds. I don't know if that's correct here. Uh, let's just say it's correct, okay? Unstable and they react vigorously. Okay, I'm not sure, but I don't think they'll play with the words like this in the exam. Question 16. Write the equation for the reaction of potassium with chlorine. So we have K plus Cl2 to produce, obviously KCl. Okay, and it's 2Cl for 2 here, for here also 2. Okay, when heated with oxygen, potassium reacts vigorously to form potassium oxide. Write the equation for the reaction. Actually, it's going to be K plus O2 to produce K2O. Let's balance it. Since it's 2 oxygens here, it should be 2 over here. And since it's 4 potassiums here, so it should be 4 over here. Okay, write the equation for the reaction of potassium with water. So K plus H2O. You're reacting an alkali metal with water, so you're always going to get alkali hydroxide, so KOH, which is aqueous always. Okay, plus hydrogen gas is released. Okay, now to balance it, you have 3 over here. It should be, wait, uh, is this correct? KOH plus hydrogen gas. Let me double check, but you should balance it. Uh, let me see. Okay, question 16. They put coefficient 2 beside everything. Okay, does that work? 2 here, 2 here. Okay, so you have 2 of this. So if you put 2, 4. Yeah, okay. But hydrogen gas shouldn't get the 2 beside it. Yeah, it doesn't. Okay, yeah. Yeah, I think that's correct. Let me check the other ones as well if they're correct. You have 2K plus Cl2, yeah. 4K, okay, they're correct. Explain how you could distinguish between lithium chloride, sodium chloride, and potassium chloride. So we have lithium, Li plus, we have sodium, Na plus, and you have potassium, which is K plus. How would you distinguish between the three? We always know the flame test. So you would say, upon heating it with a flame, lithium chloride will produce a red flame, sodium chloride will produce a yellow flame, and potassium chloride will produce a lilac or violet flame. Don't say purple, Please don't say purple. Okay, so you can say a flame test can be used. And then obviously you have to show the result for each one because they said explain. They didn't say what is the test. Okay, this one here, I'm gonna skip it. We get it all the time. Okay, using your knowledge of covalent bonding, explain why hydrogen is a diatomic gas. It should just be because it's a nonmetal. When H atoms share electrons, each one feels 2 electrons around it. This is the same as helium. Oh, okay. Why is it diatomic? Why is it 2? Okay. You know, guys, like, let me put up the periodic table. Wait. You guys know with covalent bonding, you share electrons, and the whole point of covalent bonding is to share electrons, so its electron configuration can be like the nearest covalent, nearest noble gas. So, for example, when I have NaCl, Na will share, and no, and that doesn't. Na, like with NaCl, Na loses an electron, so it would be 11. It becomes 10, like neon, and then Cl would be gaining this electron from Na to become 17, turns 18, like argon. Okay, so that's for ionic. But انا عم بقول هلا covalent. Okay, for example Cl2. Okay, Cl has 17. But let's just say 17. Okay, and you have another Cl 7 because you know Cl doesn't have Cl2. It's diatomic and it's covalent bonding. Okay, so it's gonna share an electron. So this it's gonna take an electron. It's gonna be in the middle. Okay, so now it's being shared between both of these Cls. Okay, so this one would feel like it has 18. This one would feel like it has 18. And who has 18? The nearest noble gas, right? So that's why it shares electrons to feel like the nearest noble gas. So when they say why is hydrogen diatomic? Because hydrogen tries to be like helium, right? So how many hydrogens do I need to have 2? I need 2 because it's 1, right? So I have hydrogen over here which has 1, and I have hydrogen over here which has 1, and then they share it together to become like helium. For over here, when they say that hydrogen tries to become diatomic, it's because it is trying to become like helium. Okay, when a spark is introduced to a mixture of hydrogen and oxygen gas, an explosion takes place and H2O is formed. How do you explain the existence of stable H2O molecules? Okay, I'm going to show the solution. I'm not going to make something up because I'm going to try and give you the exact answer. And I'm going to explain the answer given. Okay, in H2O, right? Every hydrogen in water shares its electron with O. Okay, so it looks like this. O, H, H. Okay, so O shares its electrons with both of these two H's, right? As a result, each H feels like 2 electrons around it. So if you were to write it like this, okay, you have O, 1, 2, 3, 4, 5, 6, because oxygen has 6, it's in group 6. You have hydrogen over here, which has 1, so like this, and you have this hydrogen over here, like this. Okay, so oxygen now feels like it has 8 because it's 1 from this hydrogen, 1 from this hydrogen, and has 6 from itself, so it feels like it has 8. Okay, each hydrogen feels 2 electrons around it, right? Because why does each O feel like 8 plus 2? Hold up. Now I'm confused. Wait. Yeah, it has 6 in its last shell. Sorry, huh? It has 6 in its last shell, but it actually has 8 because oxygen is 8. Okay, it's the same thing. Don't get mixed up. Okay, total electrons. We're not talking about the last shell here, and I drew something else. Okay, oxygen has 8. Now it took 1 from here, 1 from here, so it was 8. Now it has 10. And who has 10? Neon has 10. So now oxygen became stable. Okay, how about let's take a look at both hydrogens. Hydrogens had 1, but now they both have 2. 1 plus 1. And who has 2? Helium. So we can say, oxygen gained 2, so it feels like it has 10 electrons like neon. And then then the hydrogen feels like it has 2 like helium. Okay, and you can say they both achieved the noble gas configure, blah, 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 blah. Okay, question 20. No, oh, where am I going? Okay, question 18. Okay, a salt S is dissolved in water. When a silver wire is dipped in the solution, okay, then placed in a flame, the color turns bright yellow. So obviously the flame is Na+. Okay, when a few drops of silver nitrate, white precipitate forms. So obviously Cl. Okay, minus. What is S? Obviously S is NaCl, but we do not want it like that. Give a convincing explanation. Okay, in the explanation, we're going to first explain the yellow part, okay? The yellow part, we can say flame test when a flame shows yellow. Uh, when the flame turns yellow, you can say it's sodium. Okay, then you can say upon adding silver nitrate to a halogen and it forms a white precipitate, that means it's chlorine. They said use a balanced equation, so let's write it like this. So when a few drops of silver nitrate are added to the solution of S, so silver nitrate is AgNO3. Okay, we know the solution S is NaCl, right? So plus NaCl, right? Okay, to produce. What is the precipitate? It's always Ag with the halide. So AgCl plus, just continue the rest, NaNO3, sodium nitrate. Okay, so I guess that's what you're supposed to do with question 18. Okay, so the color of the flame turns yellow, so that means Na is present, and a white precipitate formed with silver nitrate, that means Cl minus is formed. Ag plus, they didn't use NaCl, they just used, okay, okay, yeah, this also would get you a mark, by the way. They did it a bit simpler. You could do this as well. Okay. Uh, Question 20, when silver nitrate is, so AgNO3 again, is added uh, to a solution of sodium chloride, sodium bromide, and sodium iodide, we'll observe the following respectively. Why? Okay, this is the answer. We're not supposed to know this. Okay, obviously for sodium chloride, it's going to be white. For bromide, it's going to be creamy. And for iodide, it's going to be yellow. Remember, ILW, I love yellow. Iodine loves yellow. Okay, question 18. If given a solution of NaBr in water, which is true, okay, in water, don't be confused here, okay? The only thing here, if you realize, it's talking about the displacement reactions, okay? When you have this halide and this halogen, remember that's the displacement reaction. For that means we're using the halogens, FClBr, IAT, right? FClB. Okay, and we know the reactivity decreases as you go down. And we know that the halogen, the one with 2 as its subscript, should be more reactive than the halide. Okay, so let's see. Will bromine be released if we add I2? Is iodine, you have to ask yourself, is the halogen more reactive than the halide? Is iodine more reactive than Br? Let's see. It's not, so the first one's wrong. AT, is it more reactive than Br? Let's see. AT, Br, no. F2, is F more reactive than Br? Yes, it is. Okay, if Cl more reactive than Br? Yes, it is. So only C and D. Okay. Question 19. A white solid M was dissolved in aqueous solution Z. To a few milliliters of Z, chlorine was added, okay, and the solution turned brown. Okay, brown. Brown meaning it's either, okay, iodine or bromine, okay? But how do you distinguish between them? From this, when you add CCl4. Okay, they said when you added CCl4, it became purple violet. That's how you know it's iodine. Okay, when a platinum wire was dipped into, how I know this, by the way, is from the table over here, somewhere over here. Yeah, iodine in CCl4 is purple, but for bromine, it's orange in CCl4. Okay, and let's go back to the question. Uh, where am I? Yeah, here. Okay, when a platinum wire, okay, the flame became lilac violet. Okay, uh, if it's lilac violet, that means it's K. What is M? Obviously, it will be Ki. What can I write here for a balanced equation? I don't know. Let me check the answer. Okay, it's Br. Okay, M is potassium. Ki. Did they say it's dissolved in water? Ah, yeah, they said it's dissolved in an aqueous solution. Ah, okay. Okay, yeah. But since they said it's dissolved in aqueous, that means akid it's dissociating. Okay, so that's your first one. Okay, then, well, the last one is a bit far-fetched. I didn't really think about this one. But they said it's dissolved in chlorine, right? So Cl2, right? And we have here I, right? So we know Cl2, it's a displacement reaction, sorry. Cl2 plus I minus becomes I2 plus 2Cl minus. أكيد balance it, huh? Is this correct? Yeah. So this is the displacement reaction. Question 19. Under room temperature, what is true about hydrogen? It's a diatomic gas. Yes, it has low melting and boiling points. I don't know, does it? Yes, okay, it does. It's up here. It's the lightest known gas. Okay, yeah, this is easy. Where am I? Hydrogen reacts with alkali metals to form a white solid. Okay, you're not supposed to see this. Okay, right reaction between potassium and hydrogen. So K plus hydrogen we know is always diatomic, H2. Obviously you're gonna get potassium hydride, right? To balance it, you have 2 here, 2 here, so put 2, 2. Okay, and it's over here. And from the question, it forms a white solid if I put solid, okay, and potassium, yeah, I guess potassium is solid, and hydrogen is always gas, okay. It's an alkaline metal, فأكيد the potassium is a solid. Okay, write the reaction between potassium and bromine, okay. So, K plus Br. Br is diatomic because it's group 7, remember? Okay, Br2 to produce KBr. Now you just balance it. It's going to be 2 here, 2 here, for 2 here, 2 here. This is a solid. This is bromine is a liquid, remember? Okay, the only two liquids in the periodic table are mercury and bromine. Okay, and then KBr would be a solid as well. Because it's ionic, by the way. Metal, non-metal, so it's going to be ionic. Write what happens when the product of each reaction is placed in water. Show in what way hydrogen is different from the halogens. Okay, so when you put KH in water, so let's say KH plus H2O. Okay, whenever you have a reaction like this where like you have hydrogen and something, okay, and remember when you have the alkali hydride placed in water, you always get the alkali hydroxide. So K, it always becomes KOH. Remember, this always becomes KOH. Okay, and what are you left with? Plus always H2 gas, right? This is aqueous. Okay, and if you can you balance it? It's already balanced. Okay, and then how about for the KBr? KBr plus H2O. You're gonna get here. It's only gonna become K plus Br minus. So Walid, what happened? Why is there no reaction? But look, what is this? This is an ionic compound, right? What happens when you dissolve an ionic compound in water? It dissociates to form ions, right? Two different ions. Okay, remember, and it's also conductive solution when you dissolve it in water. Remember all these things about ionic compounds? Exactly. So you have to use them here. Okay, so here you're gonna get ions. Okay, show in what way hydrogen is different from the halogen. I don't know how's it different. In the first reaction, hydrogen gas is produced. In the second reaction, ions are formed, so it dissolves silently. Okay, yeah. I guess you could say when hydrogen is present, uh, hydrogen gas is okay. Yeah, this is a stupid question. This part. Okay, but they could ask you something like this first part. Okay, hydrogen and alkali metals react with chlorine. I'm gonna zoom out a bit. I don't have space. Uh, write the reaction between chlorine and potassium. So K plus Cl2 obviously produces KCl. Okay, balance, solid, gas, solid over here. Write the reaction between chlorine and hydrogen. So H plus Cl. Okay, H2 plus Cl2 to produce 2HCl. Okay, this is a liquid. Is it a liquid? I saw it somewhere here. Uh, uh, is it? It's a gas. Oh, it's a gas. Yeah, gas. Okay. Oh, whenever you have HCl, hydrogen fluoride, any acids, they're usually gases. Okay, hydrogen obviously gas, gas. Okay, show in what way hydrogen is different from the alkali metals. Okay, again, it's the same thing. What hydrogen forms a covalently bond gas when it reacts with halogens, while alkali metals produce ionic crystals. Oh, so over here you could say, when it reacts, from the here it said alkali, and here okay, that's different. Okay, uh, here when hydrogen bonded with chlorine, okay, we got a covalent bond. But when it bonds with potassium, you guys know KCl is ionic. Okay, so how is it different? How is KCl different from HCl? This is ionic, this is covalent. Okay, right, what happens if a use equation was possible when it's placed in water? Okay, same as the previous question. So let's say KCl plus H2O. What happens when you place an ion compound in water? You get K plus and Cl minus. Obviously balance, Cl, 2Cl minus. No, you don't need to put 2Cl minus. Sorry, do you need to? No, you don't. Then the last one here, HCl, right, plus H2O, it will also dissociate because it's an acid, right? We said acids, remember, acids dissociate to form conductive solutions and ions. Okay, they're the only exception for the covalently bond. Okay, what dissolves and dissociates in water? Always ionic compounds and acids. Acids are the only covalently bonded exceptions. And then they said, how are they similar? Obviously, since they both formed ions, then they're going to be similar. Uh, so, yeah, I guess that's it. We're almost done. Yeah, okay, okay. I'd recommend you to memorize this table. It's all easy to understand. In my previous chem video, I think at this point, you should have watched it, but I explained it somewhere else. You have to memorize this. You have to know that it's molecular, covalent. You have to memorize this, and I think you have to memorize this. You have to memorize this, and you have to know it's a network solid, and you have to memorize this before O10. Okay. Uh, Also this one here, SO2, SO3, Cl2O7, Cl2O. Okay, know always that argon has no reaction. Okay, AlCl3 dimerizes in case it comes. Okay, to form Al2Cl6. Okay, here just write reactions. The equation for sodium and sulfur, so Na plus S. To produce, is it just NaS? Na plus S2 minus. S2 minus, S is 2 minus Na plus. Uh, let me check that. Yeah, I don't know what I'm writing. Okay, the first step for this is always find out what compound we have. We have Na plus, and you know sulfur is S2 minus. But if you crisscross, you're gonna get Na2S. Okay, so how do we form Na2S? We know Na plus S to form Na2S, right? Let's balance it. Okay, it's two sodiums. Okay, now is it balanced? Yes, it is. Do you need to put state symbols? Oh, you do. Okay. This Na is a alkali metal, so solid. Sulfur, I guess, is a solid, and Na2S in that case would be a solid. What are the bonds? You have metal, non-metal, so it's gonna be ionic. Or ionic. Okay. Magnesium with chlorine. Okay, let's figure out what we have. Mg2 plus is magnesium. Chlorine is Cl minus. Crisscross, you get MgCl2. Okay, so Mg plus Cl to produce MgCl2. هلا balance it. You're gonna get 2Cl. Okay, is it balanced now? Yes, it is. Now it's metal, non-metal. So again, ionic, ionic. Okay, aluminium with oxygen. So Al3 plus and O2 minus. You're gonna get Al2O3. That's the one that was over here, right? Al2O3. Yeah, okay. Uh, so that means aluminium plus oxygen, O2, to produce Al2O3. Let's balance it. Okay, here you have 3, here you have 2, so okay, you have to multiply this by 2, multiply this by 3. So now it's 6, 6, but this is 4 here, so this is 4. Bonds. This is metal, non-metal, so okay, ionic, ionic. Silicon with oxygen. Let's erase this over here. Silicon is Si, I think, Si4, 4 plus. Was it 4? I think. Okay, oxygen is O2 minus. Okay, you know, this one's one of the exceptions, so it forms SiO2, right? So we're going to put Si plus O2 to produce SiO2. This is one of the exceptions over here, silicon with oxygen. Okay, we know that the bonds are covalent, okay, but it's a molecular solid, or sorry, it's a network solid. Network solid. Okay, silicon with chlorine. So I think what's the charge of silicon? Yeah, I googled it. It's 4 plus, huh? Oh, what happened here? Okay, so it's Si4 plus, and then chlorine is Cl minus, so it becomes SiCl4, right? So SiCl4. Okay, so silicon plus chlorine Cl2 to produce SiCl4, and I keep to balance. You just multiply this chlorine by 2. Okay, sulfur with hydrogen. Let me take the pen up. Uh, Okay. Sulfur with hydrogen. So sulfur is S2 plus, I think, and hydrogen is H, so it becomes H2S, right? When you have hydrogen in the compound, hydrogen has to be the first one. Let's put sulfur plus H2, because you know hydrogen is diatomic, to produce H2S. Is it balanced? Yes, it is. Okay, here I forgot to put the bonds. And non-metal, is it metal, non-metal? I don't know. I think it's molecular. SiCl4, yeah, molecular covalent. Okay. because it's both non-metals. Okay, so non-metal, non-metal, so akid is going to be a covalent bond, and the compound would be not covalent compound. You don't see covalent compound, you see molecular. Okay, and then S plus H2. Okay, this is non-metal, non-metal. It's going to be, I think, also covalent molecular. H2S, hydrogen, H2S. Is it here? I think it's, yeah, H2S. It smells like rotten eggs. Yeah, I remember this. Molecular covalent. Okay, so the bond is covalent and the compound is molecular. Argon with hydrogen, no reaction. So you just put no reaction, no reaction, no reaction. Okay, is this correct? Yeah. Okay, say no reaction. Don't put dash. Uh, okay, I think we're done here. Use the trend in reactivity to predict the spontaneity. Yeah, you know if it's spontaneous or not. Let's see. Cl iodine. Okay, which one's more reactive? Chlorine should be more reactive than iodine. Is it? Let's see. FClBr IAT. Chlorine more than iodine. Yes. So spontaneous. Iodine more reactive than fluorine. Is it more reactive than fluorine? No. Okay, pay attention. They might switch the order, and I think they're gonna get this in the written because they didn't get it in the periodic. I think they'll get it now. Okay, bromine more reactive than chlorine? No, right? Pay attention. Maybe they switch the order. Maybe they put some people, they could get mixed up. Kf plus I2. Okay, they say fluorine more reactive than iodine. That's correct. No, pay attention. It's the one with 2 as the subscript. So if they change the order, it doesn't matter. Remember Hess's law, because you need this in chapter 8. It doesn't matter if you change the order. Okay, 26. I'm gonna skip this. I'm gonna just put the answer because you just have to memorize it. Also, come on, I did it in the quiz. Okay. Here they said be careful. Bromine is not bromide and iodine is not iodine. Okay. Be careful, please. Okay. Uh, So يعني why this matters is because here where they say solution يعني you have to put the ion, the minus, okay? You can put Br minus or I minus. But here where they say the element, that means you have to put iodine. If you put I minus for the element, then you get it wrong. Even if it's the same thing, you get it wrong. Not even have a mark. Okay, complete. This is also in the quiz. So I'm gonna skip it as well. Okay, 7.9 quiz, question 5. Are we done here? I think we're done. Okay, question 21. Okay, I'm gonna what is there answer to this? No, there isn't. Maybe at the end. Okay. I'll do 28, 29. I'll skip this, okay? Uh, Identify the type of bond that exists between group 1 and group 6. Group 6 صح؟ metal non-metal فأكيد it should be ionic. Okay, group 6 and group 7, that's non-metal non-metal فأكيد covalent. Okay, group 2, group 6, ionic because it's a metal non-metal. Group 7 should be covalent. Group 6 again covalent. So I think they should be all covalent except A and C. Yeah, A and C are the ionic. Okay, which of the following form an ionic compound? X and W. Okay, you need a periodic table for this. C. So they said atomic number 11 and atomic number 14, X and W, and atomic number 7. 11 would be sodium, و 7 would be nitrogen. They said ionic. Yeah, أكيد. So sodium and nitrogen, metal non-metal فأكيد ionic. X and Z. So X and Z, 11 and 16. So again, sodium, 16 is sulfur, metal non-metal فأكيد it will also be ionic. Y and Z. Y is 14, Z is 16. 14 silicon is a metal, and 16 would be sulfur. Yeah, metal non-metal, that's ionic. Y and W, 14 and 7. So 14, which is silicon, 7 is nitrogen. Yeah, that will also be ionic because metal, non-metal. Silicon is a metal. Okay, Z and W, 16 and 7. 16 and 7. That should be covalent. No. I know for a fact E is wrong. Okay. The diagram below shows the location of 4 elements X, Y, W, and Z in the periodic table. Which of the following statements is false? X combines with W to form an ionic compound X2W. Okay, it would help if you use the periodic table to figure out what these elements are. In this case, X would be hydrogen, W would be oxygen, and Y would be oxygen. Y would be carbon, and Z would be uh, what was it? Second group, third one down, calcium. Okay, so Z would be calcium. Okay, which of the following are false? X combines with W to form X2W. Okay, so X and W. So hydrogen plus oxygen. Hydrogen is plus, O2 minus. It forms H2O. So is it correct? Yes, it is. Okay, they want the false one. Z has 2 electrons in its outermost shell, in its last shell. Z. Z is calcium. It's in group 2, so obviously its last shell will be 2 electrons, right? Group 2. Y combines with W uh, to form a covalent compound YW2. Okay, so here's carbon, oxygen. Carbon is, I think, 1, 1, 2, 3, 4, 4 minus. Okay, O2 minus. You get CO2, obviously carbon dioxide. Okay, is it correct? Yes, that's correct. Z has more metallic character than X. Z than X. We know X is hydrogen. Obviously, Z has more metallic character. Calcium has more metallic character than hydrogen. Obviously, hydrogen is a gas. W is a group 6 element in the periodic table. Okay. Obviously, they're all correct. Why am I missing something? أيوة. Okay. I think they're all correct. I'm not sure. If I'm missing something, please write in the comments. But I think for now, we're done chapter 7. Thank you so much for watching. Good luck.